Hello, everybody. Welcome. This is the Moog Matriarch, or Moog. Gosh, hush my mouth. I'm in the presence of some Moog people, so I should say Moog. But I will apologise right away now that I will probably say Moog a few times. I can't help myself. I thought I'd start with just a little bit of a sound that I've got on the Matriarch. This is a podcast to do, well, it's a live Q&A of the Moog Matriarch, so I'm going to play this sound that I've got. So let me just make a few notes here. Live because I play a load of bum notes in there. But with that introduction, I think what we'll do is say hello to everybody who's participating. We'll start with Mr. Mark Crowley, who's a Moog hardware engineer, who's there in the conference room in Asheville. Very kindly, you actually worked on the hardware, the Matriarch, and the Grandmother, right?
I did. Yeah, I was the lead analog designer on the Matriarch and the Grandmother.
Ah, cool. So we've got good provenance there, and we've also got Mr. Amos Gaynes, who we regularly see. And I have to, you're probably just as shocked as me if you haven't seen Amos for maybe a few months. He's gone fully beard. You've gone wild, Amos. Yeah, it suits you. You look very kind of distinguished. How are you?
Oh, well, thank you. I'm feeling very well, thank you.
Excellent. I'm glad to hear it. That's good to know. In fact, I should say. Hello to, I hope you're both well, actually, chaps. And I forgot to ask, what with the world situation and everything, we should probably say, how is everybody? And I hope you're all doing okay, but we can tell that you're aware. I guess, Mark, you're at Moog HQ, and Amos may be at, not at Moog HQ. But I don't know.
No, this is my home just a short mile away on Bowcatcher Mountain, overlooking downtown Asheville, where the Moog factory is located.
Ah, cool. Well, so the purpose of this is really just to sort of open up a little bit, talk some nerdy tech about the Matriarch, but also, maybe try some patching examples. I'll start with what I was doing there, just because I think it may spark some ideas. What I'm actually doing in this patch is I'm using the rate of LFO that's on the utilities here the utilities LFO to modulate the rate of the main LFO, but I'm also using the main LFO to modulate the rate of the utilities LFO. So there's kind of cross modulation. So you get this kind of weird, like erratic. If I bring the, one of them is if I go to single voice, one of them is sample and hold. The other one is modulating the pulse width of oscillator 2 on its own. And then I was switching the delay in and out because a little trick here, if you set the tempo of the ARP sequencer really low, and then you turn the sync button on here, you get a very slow and kind of weird clocky aliasing delay. So anyway, that was my initial contribution. But first things first. So chaps, I'm really curious to know, there's something about this and the Grandmother both have this kind of concept of vintage authenticity, and we know that there's quite a lot of heritage going on here from the actual original analog designs. And this is something, when I first did the review of the Grandmother, the people who sent the review were very keen that it should be pointed out of the heritage, and it's really interesting because I've reviewed a bunch of Moog synthesizers, and when I first reviewed the Grandmother, I was at the point where I was kind of, I'm kind of over a subtractive mono analog voice of the same topography that I've seen again and again and again. And I was dreading that I might find it I might be a bit jaded. But then when I turned it on and when I used it, it was like, oh my goodness, it feels like that's almost the thing that everybody's been trying to do all of this time. That's what, sawtooth into a good old sort of drivey VCA mixer into a filter. That's that sound. You can't get anywhere else. So I guess, I mean, I don't know who to start with first. I guess maybe Mark, because you were hardware. I mean, obviously this isn't using all. It's using the same circuit designs as those original modules, and it's using the same kind of philosophy. But I mean, presumably you can't get all the same components anymore. Like you can't use germanium anymore. And so, was it a challenge to kind of find the essence with the newness of the equipment you were working with?
Yeah, I mean, I think that we went through all of the. I had a Model 15 on my desk for like 4 months, where I was just going through and measuring every part of all the circuits. And what ended up being were a lot of discrete transistor buffers that stayed in there because you could kind of get color out of them. And so those got left in where they hadn't always been in modernized versions of the Moog circuits. And then a big part of that too was just the CP3 and having the mixer that clips asymmetrically.
Yeah, I mean, it's definitely got a real sound to it, hasn't it? I mean, it's the because there's really quite a big difference between 12 o'clock or if you're running 4 voices into that, you need to maybe go to 3 o'clock or
right.
less, just to stop it from really blowing up. I mean, it's quite a sensitive thing. So what is it? What's so special about the CP3 that kind of allows that? I mean, you say asymmetrical. What does that mean? Is it to do with the harmonics, or what's the?
Yeah, so it clips on the bottom before it clips on the top, and it's actually because the modular rails are plus 12 and minus 6, which I heard through folklore that's because they originally ran on car batteries. But so it just clips on one side or the other, and then that boosts the fundamental in a really strong way instead of just classic overdrive,
Right.
And it's
okay.
discrete transistor drive, so it's got a soft curve to it.
It's really interesting that I mean, because if you also the folklore, I'm certainly with the Mini anyway, the idea that there was some of this sort of happy accident, this overdriving the filter design suddenly went, oh, that sounds nice. It was never originally by design. I don't know if there's any truth in that, or I see you a wry smile there for you, Amos. Is that true, or is that actually?
Well, I mean, I wasn't there at the time, a fly on the wall. I can't speak to the literal historical truth of it, but I can absolutely speak to the truth of that experience of you're hard at work on something and you're a human being. Not everything goes perfectly to plan every time, but there are those moments where something doesn't go to plan and it's better than what you had in mind. And the moment of recognizing the happiness of an accident is something that I have witnessed time and again in the course of our modern designs. That's still, experimentation is very important to what we do, and being open to, experiments where the outcome is unknown. And, a lot of times we're like, oh, well, that sounds terrible. That's why we've never done it that way before. But then there are the times where we find, there's some golden amount of drive in a place where, it was an open question what the gain staging was going to be. We find the place where it's magically, significantly better than if it's hotter or lower than, you find these Goldilocks zones as you're voicing a circuit, and that's part of really bringing a design to life. So when we get a chance to explore a circuit and find all the little corners of how it can sound, ideally, then we take note of the best and most interesting corners, and that's how we tune the circuit to bring out its most characterful voice.
Oh, that's interesting, because I mean, I would just assume that, it's like you look at the circuit diagram of the original, when you're kind of moving all the schematics and you just can build it and then that's kind of it. But are you saying, I mean, guess hardware Mark, that's not the case. Are there trimmable and sort of voicing processes that go past that, or does the schematic kind of give you everything you need to know to make it exact?
Oh, absolutely, yeah. I mean, they end up being, large complex systems, so you end up having places where it just doesn't sound right. So you start, trying out different values or different gain staging, and getting other engineers in the group to listen, and it's a lot of that kind of discovery and making sure that you're conceptualizing it as a whole instrument, not just writing down a lot of sub-circuits and piecing them together.
Right. And I suppose the other thing is because the Moog thing is so sort of golden. It's sort of so totemic, isn't it, in a way? I mean, how much leeway do you have? I mean, do you get to the point where it's like, well, that sounds great, but it's not really Moog, you know? Do you have those sort of situations where you go somewhere, but whatever it is that pulls it back into the kind of the Moogness that envelops the whole thing? I suppose I'm curious about that, actually. I don't know how. So do you get to explore those corners and then bring them back, or how does that tend to work?
Yeah, I think you get to explore them, and I haven't yet had a situation where it didn't feel Moogy,
okay.
I guess. But I've had, you just start playing it with other people, and they start having ideas, and, you know.
Yeah, no, interesting.
It's a process of tuning. Yeah.
So, I mean, I suppose the thing is there like a kind of taste panel that it has to go through, the QA, the end point, and, you know, what the arbiters of the final product? Because presumably, when you're doing something, you go, well, it could be like this, or it could be like this, or be like this, and you maybe present 3 or 4 or more prototypes, and then people choose, or then there's something in between all of those. I don't know. I'm assuming it's like a kind of focus group, but in a kind of in a more holistic way, perhaps, right?
That sort of panel of listeners and so on, that happens at various stages throughout the process. We will do, sometimes we'll have listening sessions where we'll go into the Moog Sound Lab and set everything up and bring people in either, singly or in groups to basically audition sonic ideas, or we've got the circuit together for the first time, we've got it tuned up, everyone have a listen. Sometimes we solicit written feedback. Everyone will write down their impressions and we'll collate them and go through them and really take it seriously. But that doesn't just happen once. It happens at various points over the course of developing something new.
Interesting. So is there a point at which there's a kind of I've lost my train of thought there. There's a point at which where it's decided. That's what I was going to ask. Is there a golden listening path that any Moog product into the thing that you always make that sort of decision on? What is it? Quad amp and a pair of electrostats. You know what I mean? Is there a sort of a specific monitoring setup that if it sounds that way on that thing, the reference system? I'm just curious about that as well. Is there a reference?
No, not really. I mean, we're pretty in my experience, basically everyone has their own personal listening setup that they are accustomed to. But when it comes to to what you're talking about, there isn't one specific, this is what we always use setup. And part of that's, we may yet have that. Typically we tend to use some focal monitors in a nicely treated room, but then if we, for really critical listening, a lot of times we will rent time at a local recording studio and use their really nice monitoring setup. Like, what's their name? Something Mountain. Mark, do you remember the name of the... Echo Mountain. Yeah, Echo Mountain is a really nice studio in downtown Asheville. They have, they have really beautiful A and B mixing rooms, and then, so often we'll take a new piece of hardware there, and that's where we'll do the most critical, detailed listening.
Interesting. So, I mean, coming back to the original designs here, I mean, I foolishly thought that the oscillator was actually the 921, but Mark, you put me right that it's actually more. The Voyager oscillator is kind of what we've got in the Matriarch, right? I mean, with the saw core, is that right? Am I speaking the right words?
Yeah, it's the Voyager oscillator, which is kind of Bob's final incarnation of the mini Moog oscillator, and so that's the oscillator with. It's super stable. It tracks well. Sounds big.
Yeah, I got that. Does it need? Is it supposed to have some warming up time? Because I didn't really notice there was any kind of, with a lot of analogs you need to leave them on for a little while, but this didn't seem to. The tracking seemed to be very good with it. Is there there's probably a trick to that, but.
There is a little bit of warming up time, but they all kind of vary depending on each one, which is why they get calibrated.
Yeah, of course. So, the other thing that's a big deal is obviously the filter in this guy. When you decided, because obviously Grandmother obviously spoke to a lot of people. Did you have them both planned when you released the Grandmother, or was there a natural evolution in terms of I know, let's do it this way and make this a paraphonic,
Oh,
either of you.
I was expecting
Amos.
you.
Sorry, I was supposed to.
Yeah.
Transatlantic delay. Yeah.
No, that's and there is a little bit of a delay. It's fine. It's a good thing I can't hear myself, or I would be totally tongue-tied with the delay. I mean, so to answer your question, I'm going to throw that over to Mark in terms of how much was planned from the outset, because I'm not as clear on that. But I do think that it was in terms of how did the matriarch come about, it was very much an evolutionary sort of thinking. But then as to the specifics of how did we go from, the one filter to this precisely the filter configuration that we ended up with, that my recollection is that there were some twists and turns, and since Mark was driving that, he would know more details.
Right, okay, because, you decided to go stereo, which is a big kind of change. Why did you choose to go stereo at the filter rather than maybe at the oscillator or the mixer? What was the kind of thinking behind that?
Well, the idea is to have, one, the filter is kind of a different version of the Voyager filter, which is that stereo low pass that is on left and right. We also I think that having it at the filter means you can kind of have these controls all the way through and not have kind of nested controls, right? Because you would need two mixers and then you wouldn't have an opera function exactly, depending on how it worked,
Yeah.
So it felt like the filters and the delays and then VCA, so you could do panning things.
Right, well, which because we go into the delay as well. I mean, actually, I should point out, for those of you who haven't watched the review, I reviewed this. A review was released last week. There'll probably be a link somewhere in the description of this when it finally goes out, but you'll be able to find it. It's on the channel. One of the things, I found that the stereo is actually really handy, and the sound. I suppose the question I'm skirting around here is, the classic Moog ladder filter. It's got that really creamy sort of beautiful driving sound if you pump it hard enough. But it's also got this, massive loss of low end, or certainly significant loss of low end when you bring the emphasis in. One of the things I've said previously in subsequent Moog releases is like, I wonder if like a button that just put that back, bass compensation thing would be something that you consider, or is it so sacrosanct that you don't want to? You don't want to deal with changing that. Does it have to be classic, or is there a kind of reason why you haven't done it? I suppose is the question. I don't know who wants to maybe take that. I suspect neither of you really want to take that question, but I've asked it nonetheless. So I'll go to you, Amos, because
sure. The simplest answer is that if the brief is to create a new instrument with literally taking from, for example, the modular series. If we are drawing explicitly and directly from our own heritage, then those instruments were released with the filter topology as it is without the compensation. Typically, you'll find those, resonance, the bass loss from resonance, those compensation circuits you'll find in clones, essentially, or in non-Moog takes on that filter. And so, not that we are in any way I don't think that we are prohibiting ourselves from going in that direction, but it wasn't the first choice if what we wanted to say was, this is the filter from the Model 15, let's say.
Right, I see what you're saying.
Mark was probably more directly involved in any discussions of that. That's me surmising what we probably thought, but Mark was probably in the room.
Is it possible to do both? Without kind of compromising the original filter design. I don't know how one does bass compensation. I've got no idea. Presumably it's just like a gain or an emphasis change or something. You'll probably know better than I do.
Yeah. Well, I think one of the benefits of having two filters like this that you can use the mono output is if you only turn up one resonance, then you kind of get that compensation, right? Because you can set the two filters where one low pass is not losing the bass and the other isn't, which is apparently an old Quincy Jones trick. He used to use too many Moogs or something, but so you can kind of get that on this instrument, which was
right.
Kind
Turn
of a
the
nice way
resonance
to
up on one.
Oh, that's interesting.
And then leave the other.
Okay, well, that sounds like a patch example. Maybe we'll get onto that.
I've got another. Well, I just want to interject one more, secret producer trick. and this comes from my dear friend Kevin Lamb, may he rest in peace. One of his tricks was to take a high-pass filter and crank up the emphasis on the high pass, but then turn the frequency right down to the bass, so that the high pass is creating a boost of exactly the fundamental that you want, and then do your regular filter sounds using a regular low pass in addition to that.
Yes, I've seen that, but I mean, this actually introduces an interesting question, because I tried to do that on this and I couldn't get those really massive boosted high pass resonances. Didn't seem to go down as far as I had expected, and I don't know what quite is that actually
well, and that's
here?
another characteristic of this very, oldest grandparent of the low pass filters. The very, very original Moog filter isn't known for, raging bass on the high pass. It's just, the response isn't as peppy in that region on that particular topology. So again, this is like, but there's two things. You opened by saying, finally, for the first time, they somehow nailed that mysterious magic. And
I want it all.
These
Amos,
things are
that's
related.
why. Yeah. Can we have everything all at the same time, please? Yeah. No, that's a fair comment. So the other thing that was interesting, because obviously there's quite a lot of firmware going on here. I mean, one of the things that I suppose the issue that I had, and one of my criticisms, of which there were very few actually, because I would like to say it is a great instrument. As an instrument, it really kind of works. Was there's all of this stuff. If I switch to this shot, I can show. So basically, the shift, hold, sync, enable, where you can then access a mode where certain key commands will, key presses will do things like switch local off, etc., etc., etc. And there's quite a lot that you can do in that. Obviously, it's hard to see what the status is, but I think that was my only criticism. But I don't know if that's that would be a question I suppose I would ask. I mean, is that something that can be easily addressed in firmware? How much can you do in firmware?
Well, you're always it's always down to how the hardware lets you get at the firmware. Sort of what are the hooks that you have both for input and for feedback. And in the case of this instrument, basically all of these global settings, the reason that it's as involved as it is because the system as a whole, the firmware, you're like, what can you do? What can't you do? There's really so much that you can do in terms of the subtle behaviors of the instrument.
Right.
Excuse me, spam call, pretty sure. So at any rate, because as you work with this instrument, it becomes clear that there are very good reasons why you might want it this way, or you'll have camps of users that have very strong reasons for contradictory needs, and so you add a global setting to set it this way or that way, because in firmware it's absolutely up to you whether it's this way or that way, if we're talking about all the behaviors that are on those menus. So the instrument was designed without any of that in mind. In terms of the hardware UI, it was like, this is a vintage, the experience should be, you walk up to this instrument, you turn it on, you turn the knobs, it sounds like, it looks like it's going to sound, simple vintage experience. And yet, in order to do everything that we wanted to do, there's firmware powering all of those behaviors that look so simple on the surface.
Yeah. So
you end up with a little bit of a conundrum that you have an extremely powerful system with an extremely simple interface. And what do? So I had one LED that I could reasonably blink. If I started blinking other LEDs, it's like you don't... the ideal is that you shouldn't need a cheat sheet to operate the instrument. In a case of something like this, you basically, there's a divide, and on one side of the divide, there's a screen that is updated and, has text on it or graphics and stuff like that. And, that's, if you don't have that, then either you have to choose very wisely a very small set of capabilities and just it only does what it shows on the surface, and that's enough.
Yeah.
If that's not enough, then you're in this gray area where you need to add capability, but it can't look like a computer, and it doesn't give you the kind of feedback that a thing with a display would have. So in various instruments, I think the Minotaur, the Sub Fatty, the Matriarch, all of these instruments are in a similar situation, that they were designed to look vintage, have a very simple interface, and 90% of the time, that's all you need. You turn the knobs, you play keys, you're making music. You're not operating a device, and yet these are devices. They have complex features, and they wouldn't be as good as they are if they didn't give people those, the ability to customize its behavior for exactly what they need, and that's what drives. That's what drives packing all that stuff in.
I think one of the things that would probably be a smart thing to be able to do is just like a simple app that you can plug anything that will read USB and just go, what's the current status of it? I need to switch that off.
Absolutely.
You don't know what, because I got this as a review unit. I have no idea what's been set in it. I might be going, oh, this is terrible. It doesn't work properly. And then it's like, oh no, it's this setting. And I would never know, I suppose. So that's the kind of
precisely
that's the stuff you have to, yeah.
Yeah, yes, something like that would definitely, the ability to have an overview of like, here's how it's set up. That's really the place, I was talking about, how do you see what you're doing? How do you access these settings? But how do you review the state that a complex device like this is already in? You're right. That's a place where, we could provide that window for the user, and that would be a real value add. That's something, something for us to look at as we develop things in the future, for certain.
Okay, well, I wasn't trying to make you squirm there, honestly. So, so Mark, you worked on both the grandmother and the matriarch, right?
Yes.
Which is your favourite? This came out of the chat room. Somebody said, you got to ask them which one's their favourite. And I just thought, oh, that's an interesting question. So I'm going to do that. I'm afraid it's gone past and I didn't get their name.
Okay. I don't know what I would say. I think they're both very different instruments. Going back to what you were talking about before of how the matriarch came out of the grandmother. Yeah. It was a lot of the grandmother was one thing. We wanted to make it simple, intuitive, and like a way for people to start exploring patching and playing with these old modular circuits. But there were a lot of like, oh, would it be cool if it had this? Wouldn't it be neat if it had that? And so we started making a list, and then slowly those things developed into, oh, well, let's make two of them, and we'll have one be kind of big and one be, the more straightforward one. So I think they both have a place. I think that the grandmother feels more like a keyboard to me, and the matriarch feels more like a modular.
Yeah, no, I get that. I mean, I did find that when I was patching, you can that's not the one I want, it's that one. You get very quickly into a big nest of cables, and, that, which is fine, because there's quite a lot of space here. And that can work, but you still do get, and you do that thing where, in most cases, the connections are sort of away from the control, so you haven't got, apart from I need to tidy my room, obviously, because this is a bit of a mess. Okay, my next question is, because I said we were going to try some patching examples, is there anything, because one thing that really came up, the use of the attenuverters, the fact that you can just use a constant voltage to pull down oscillator into LFO territory, or you can also use the LFO, the main LFO, this guy, as an oscillator. No, this guy, I beg your pardon, this guy is an oscillator in its own right. I mean, fantastic stuff. Are there any little nooks and crannies I could explore, which isn't going to take too long to set up now? I'll come to you first, Amos, because you said you had something I could try. So I'm going to go we'll go to this shot and I'll stand up. Okay, so I've got my fist of cables. What should I do?
Okay, this is very simple. This is a way of exploring one of my favorite easy ways to get kind of vocal formant vowel-y sounds out of this architecture.
Okay.
And so the simplest way to do that is a hard synced oscillator doing filter FM. And so what I'm going to suggest is that so we're going to patch from the wave out of oscillator 2, which I see you've set up hard sync on oscillator 2.
Yep.
And patch from the wave out of that, and let's use one of those handy attenuverters we were just talking about, patch to the input of one of those.
Yep, okay.
And then from the output of that, you can go to the cutoff 1, filter 1 cutoff input.
Right, I'm going to do that there, and I'll use a shorter cable because wave out into
so
there.
Typically the way this, what I'm going to recommend, first of all, put the polyphony switch in mono.
Yep, got that.
And let's listen to only oscillator 2, the synced one. Okay. Actually, no, I'm sorry, only oscillator 1.
Okay, got that.
Yeah. Okay, so we've got a nice low bass sound on it. That's good.
Yeah.
And now, what we'll want is enough resonance to get it a little bit peaky, and we'll want the cutoff down rather, because the modulation is going to bring it back up.
Okay.
So
right,
not quite enough cutoff to be whistling. That's all right. Yeah.
Do I need to set the
some
resonant
offset.
common to both of these? Sorry, offset there.
You might do. I don't recall how I had my filter set up. I think you might have it in stereo. I might have had them in series.
Okay.
In which case you definitely don't. So you really only need the resonance up on the one you're modulating. All right. So now let's turn up that attenuverter and see what we get. Okay, that's... turn it down some. See, now this is like if this was a cooking show, I'd just have my synth off to the side, which in fact I do, but it's so far off to the side that it's probably
getting the resonance. It's getting the resonance right, isn't it?
That's part of it, and also let's look at the frequencies of our relative. So you've got the oscillator we're listening to is very low, and the oscillator that's doing the syncing is relatively high.
Yeah.
Let's turn it down to maybe the 8-foot setting, and then play with the cutoff frequency, the oscillator frequency, oscillator 2 frequency. There we go. Now we're starting to get there. Okay, a little bit too. All right, turn down the depth of modulation a bit. We don't really just want to tick
there
a
it goes.
little bit.
There it goes.
Yeah, there it is. There. Okay. Yeah, so there.
There it is.
That's it.
Quite often it's there is the magic moment, isn't there?
Yeah. And so you'll find if you play with the depth and the frequency, you'll get all kinds of ooh, wow, 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 wow kind of noises. And now for a nice little trick,
Yeah.
you can also patch from the keyboard aftertouch output and patch that into the depth of that attenuverter. And that way you have pressure-based wah, wah, wah noises. And so if you dial in at this... Yeah, so once you get that, it's a matter
I'm trying to find that.
Oh, sorry, it's like second from the left if you're looking down, I think. KBAT.
That's it. Into the depth. No, that's not it. There it goes.
There it is.
Well remembered.
All right. And yeah, so you can hear when you over-modulate it, it loses that vocal character. But there's a range where it's really quite good. I'd also want to make sure that your waveform is a sawtooth, by the way. It might not be.
On the
On the modulating oscillator, on the sync to oscillator, oscillator 2.
Okay.
Make sure oscillator 2 is... All right. At any rate, I promise you that at all the correct settings, you get some very nice vocal.
We were there for a minute. I think we just
there.
went with one modulation too far.
Essentially, take a hard synced oscillator, filter cutoff, and then adjust the frequency of it relative to the frequency of what you're hearing.
Right.
And you get some nice vocal sounds. And of course, another fun thing to do, we've attached aftertouch to that, but you can have a lot of fun using an LFO to create a rhythmic pulsing for that modulation. Any kind of modulator into the depth of that FM gets you into some very fun territory. Yeah, maybe throw some delay on that, and then it'll be good. And you can also this is just a flavor. You can of course mix in the other oscillators, and have that just be one little character added to a regular sound. Yeah.
Oh yeah, that's nice.
Yeah, it's good if you bring it in just as a flavor.
This brings me up to another question, actually, because usually when you hard sync oscillators, I mean, I've always been taught that what you do is you use a square wave as the modulator and to have it quite high for that classic sort of sync sweep. But you get some really interesting, almost sort of pulse width modulation sort of, I hesitate to use the word, I mean, why not, it's me. But it's a very different sort of sync sound, isn't it? That when you sync two together and you set, let me just see if I could do that. So we'll just do sync and forget about that. Let me see. that's what we're used to hearing. Oh, let me
Yeah.
go to my shot. That's what we're used to hearing as a classic sync. But when you go down, you get this really. What is actually happening there? Is it actually post-width modulation, or is it just sound like it?
Well, it's phasing. What it's doing is when they're close enough in frequency, the synced oscillator still does have to be a little bit higher in frequency because the signal goes away entirely if it's lower in frequency. But when they're right near each other, you get the phasing. You know, the slow phase cancellation between the two of them happens while you're hard syncing as well. And so it's doing the same thing, but it's like instead of jumping through the whole harmonic series, you're just like shifting your harmonics a little bit in a way that's akin to how pulse width modulation shifts the harmonics a little bit. So it is doing the same thing of animating the overtones in a subtle way that's sort of smoothly rolling.
Right. Okay.
Which of course is very pleasant to listen to.
It is. Yeah, it's lovely. Mark, I've got a question for you now as well, which is why did you go? This is what was the design thinking with getting the sustain on the fader as opposed to the decay? Because I would have always felt that kind of you'd have more of a express. I mean, it works pretty good, but I just wondering what the thinking was behind making these faders on sustain rather than decay.
Well, I think part of it is right that sustain is a level and attack, decay, and release are times.
Yeah, I suppose.
So they're different in that way. And also I think, it's kind of fun if you use the filter envelope to control the filter. You can kind of play the filter with that envelope. With that fader.
Right, okay. I think I've got... I don't know, I had something here. No, it's not. I don't think it's set up. Okay, no, that's curious. I mean, I get what you mean by that, actually. I mean, that sort of does make sense when you put it like that. Okay, so the next question is, what is it that you've got for me to try? So this is harder than I thought doing it from afar, but I thought we'd give it a try, and I did put it in the video description. So Mark, what's your thinking? What should I try? I'll clear the patch up.
So I think I have smaller pieces than a whole patch, but one thing I like is if you use the attenuators as ring modulators. So if you plug two oscillators in there.
Okay.
Into the two inputs.
That wave out?
Wave out into attenuator in, and then another wave out into the control in.
Okay, and then output.
Just to a mixer channel, I guess.
Yeah.
Yeah.
Which would be output there. Yeah, why not? Okay, so
if you set those both to triangle and center the attenuator knob, that'll be your most kind of like classic ring modulator sound. And if you change the relative frequencies of the two, so if you turn oscillator 2 frequency knob.
Oh wow, I'm hearing a really, really low subharmonic coming in there, crikey. Okay, right, got you. Bit of delay on them.
Oh yeah.
Oh yeah, there's something down there, isn't there? I think we're all feeling that a little bit. Oh, that's
Yeah.
Oh, that's tasty. Okay. I think Ed actually says something about that. We got another piece because he did a piece on the attenuverters. So I hope I haven't queered his pitch too much. But that, yeah, I see. I think he does a better demo than I have. That's for sure. Okay.
I think one neat thing about that too is so the knob actually adds an offset to the modulator, so you can actually get this kind of asymmetric ring modulation where you clip on one side more than the other.
All right. Okay. So the harmonics. Always get that's almost wave when you set the frequencies together. You almost get a wavefoldy kind of.
Yeah, it does have that character.
I mean, the low end on this is astonishing. I mean, I'm glad I'm wearing big in-ear monitors. You might not get this fully unless you've got a sub on your YouTube feed here, but very tasty. One thing that I did, actually, the other thing I tried, which I won't set up now because it took quite a long time to design the patch, and this is the one thing that sort of leads back to the firmware, which was the idea of being able to switch local off on both the sequencer and the key bed. So if you take the sequencer off, that means you could use the keyboard to drive one or two or however many oscillators and the sequencer to drive another one, and you can get duotimbrality, which kind of brings up this question, which I didn't ever fully understand what the VCA mode when it's in split. What does split mode do?
So split, split will send the filter envelope to the left VCA and the amplitude envelope to the right VCA. The filter envelope still goes to both filters, but it makes it so you can have different envelopes in each ear.
So also if you're working in duotimbrality, you can have two distinct VCA envelope paths as well, right?
Right. You can patch that stuff too, but it's just a way to get it quickly. I think that part of it, once we got the whole stereo path and had 4 oscillators, it was very close to being, we can kind of do a CS15 thing here and get 2 grandmothers if you patch it right. Which we made sure that was possible.
Yeah, no, that's the thing that you can. I mean, and I guess if you've got some additional, you can access obviously the oscillators separately by, because you've got the ins and the outs all happening, where you want them to be. They'll all just sort of. So if you had external sources, you could have four voices. You would need some more VCAs and more VCA envelopes and whatnot, but you could effectively do that if that's what you wanted to get extra voices out of it. So what was the other question there? I did have another question, which I've got here somewhere. Oh, yeah. The other thing is, I'm really curious about what makes instruments, in my opinion, and where you get that sort of classic feel, and this is one thing that Moog are particularly good at, is what we call here is control law, where it's the linearity or non-linearity of the potentiometer or the control, so that, right at the off position is a little bit, and then as you add more, the granularity of that control feels very musical and natural. So it particularly works well with snappy envelopes because we've got very snap. So you can get quite a lot of detail. Whereas if you have a linear response, it almost a little bit is always too much. It's particularly with like mod depth when you're trying to introduce a little bit of vibrato and barely move the knob and it's too much. So. Is that designed into the circuits themselves, or do you actually work on that as it goes?
That's one where it comes down. I'll take the firmware side and Mark can take the hardware side, because the answer is it depends on whether the behavior of the circuit is primarily happening in, is it an analog only circuit, or is the CV for it being digitally generated, or is the pot being digitally scanned? In the cases of like on the Matriarch and the Grandmother, that's mostly down to the circuit design, and you have to tune it, and so I can't talk to that as much. But on the firmware side, I can say that yes, very much we evaluate all of those things with an ear and an eye and a feel towards, how does this parameter open up as you are turning the knob dynamically? Does it bloom in an aesthetically pleasing way, or, does it crash into, is a little bit too much, as you say? And so, yeah, we're very sensitive to that, because it does, like, the musicality of the experience of interacting with the instrument is important, not just the sound that it makes on a record, like how it behaves as you were using it is very intentionally designed on our part. And so, Mark, how does that work in analog?
Yeah, in analog, there's just kind of a few tricks. You can load down wipers with different resistors, or put deadbands in with diodes, or kind of different circuit tricks. It's just about playing with the instruments and getting lots of people to play with them, and people telling you that they can't dial in the thing they want, so then you have to kind of start playing with it and tweaking it until it feels like everyone agrees that it feels right. Whereas in firmware, I feel like Amos can speak to this more, but he can specifically define the pot curve, and he's got a lot of experience doing that, so he's...
So what? Okay, here's a question then. I always assumed that it's the what's not linear? Is it logarithmic when it's a sort of inverse?
Logarithmic or exponential. It's one of those terms, and it's almost like what direction you're looking at it from, as to which of those words you would use. Like, are you talking about a thing, or are you talking about the reciprocal of the thing? But anyway, in the analog domain, it's basically that, because there aren't infinite varieties of tapers. It's called taper when you're talking about a potentiometer. And there are physical, like when you manufacture a potentiometer, how dense the magnetic material, the conductive material is, and how that density changes over the linear distance of the wiper of the thing, like that gets designed by a hardware engineer, and you've got a couple of basic choices. You've got an audio one and you've got a linear one, and that's it. And beyond that, you have to do what Mark was saying with resistors and diodes and things to try to cheat it. But in firmware, what I use, well, maybe I shouldn't even say what I use, but what I can say is that you can fine tune very precisely how it behaves, because basically the curve is up to you. It could be anything.
Oh, so you can have like a kind of,
absolutely anything.
Anything
no,
you want.
You've got a minimum and you've got a maximum, and in between, you make your own path, essentially.
It's a bit
so
like
it's whatever
kind of,
it needs to be musically.
That's really fascinating. And I suppose if you're in firmware as well, presumably you can set state-based curves. So if this is happening, then this curve. If that's happening, then another curve. Or is that
you
going
could
too
do
far?
Absolutely. No, not at all. For hard sync is a perfect example of that. The behavior of the oscillator frequency knob is different if sync is on versus when it's off, because you want a different range for a sync sweep than you want for fine-tuning two oscillators that you're just listening to that aren't synced to each other.
That's interesting. So how does that marry with analog? Because presumably that firmware means that there's some kind of digital intervention or interaction into that path and that control thing. At what point
it just saves you money.
Yeah.
Because you can do all the same stuff in analog. You can build a computer in analog. It just takes more parts. What I'm getting at is you can define, like the Voyager. The Voyager has the pot curve. The behavior of the oscillator 2 frequency knob on the Voyager changes depending on hard sync or not. But Bob implemented that in analog. There's a DC offset that gets added. There's a gain that changes. It's the same thing in analog as we would do in firmware. It's just cheaper and easier to do it in firmware.
Okay. Well, this generates. So presumably you're working at a kind of clock rate and an update speed and a sample rate or whatever. That the digital is interacting with. What kind of rates are we talking about? Do they have to be like really high, or can they be quite? Do they not? I mean, I don't know I suppose it depends on the purpose that it's performing.
That's exactly correct. We literally determine, based on how audible these things are for a given application, what the frequency needs to be. For a filter cutoff, you've got something that's spanning 10 octaves, and it's super precise and tiny. You can hear the tiniest variation in oscillator frequency or filter cutoff. So those things they're more demanding. They have to be at a higher update rate and better sample rate and so on. There are some other things that are less, it's like, it's not as critical how quickly you update them in terms of whether you can hear that, whether you can hear it or not. So again, we listen very carefully, and we listen to the sound as you're turning knobs or as you're sending a MIDI controller. And if anything sounds, zippery or stair-steppy, or if there's objectionable noises for whatever reason, we put a microscope on that and we listen carefully, and we balance the system. We try not to overspecify anything, but we balance the performance where it's needed.
I suppose, you know how fast the clock has to be if it's ever needed it as fast as it's going to get, and you work back yes. Okay, that's really interesting. That's something I've learned something new, and I'm very thankful to that. Okay, I know I only asked for an example each, but I'm just trying to think if there's any other things that I should try out while I've got this going. One thing I'm always struggle with when I'm reviewing is when you have linear FM and you have FM built into analogs, is how to make something that sounds nice and just doesn't sound like a horrible, hideous mess. Is there like a golden ratio or a couple of settings that you could point me so that I could actually make a nice sounding FM patch?
It's the mod depth is almost always less than you think. Over modulation is one of the quickest ways to get ugly sounds. So tiny amounts of modulation, it would be my first tip, and playing lots of very stable intervals like fourths and fifths. Octaves, fourths, and fifths. As soon as you go beyond octaves, fourths, and fifths, you're going to get some bad sounds. And you just have to, you can pick one, like pick one other interval that makes a bad sound that you like and use it as a thematic ingredient. That's my performance tip for performing with squirrely analog FM.
Right, I'm now going to see what I can actually achieve with this.
Oh, and I've got another one, which is you might avoid oscillator 1 and just use the other 3 oscillators that all have fine-tune knobs, so that you can
that's a very good point.
Find exactly the stable interval that you like.
So, wave out.
I also think maybe putting an envelope to the modulation depth so you can use it to add harmonics at different periods of the time.
Oh, that's a fun one. Yeah, dynamic.
I seem to have an inverse. What's going on there? I seem to have inverted myself somehow. I'm not quite sure how on earth that's going on. Ah, there we go. That's the filter. Right. So now I've got. Right. So I listen to oscillator 3. Right, which is so I need. Yeah. So what I'm looking for is probably. Wow. Okay. I'm struggling so far, but I'm going to find that sweet spot if it kills me.
All you need is one, and then you can build an octave off of that, and maybe a fifth off of that.
Okay, so I'm going to go for. So this one is modulating this one. I'm only listening to oscillator 3. Is it true to say that triangles are often the best because you don't get too much harmonic complexity? Is that the kind of what you
I'd say.
Oh, okay. Well, I'm sort of in the right track. I didn't. Just space that.
Yeah. It's starting to be pleasing.
Pitch mod the FM. That's quite interesting. Yeah. That's better than I managed to get in the review. I feel slightly embarrassed I didn't manage to improve on what I usually used to go. Yeah, you can patch this into this, and then you go, and it's like, oh, that's horrible. I'll do the take again until it doesn't sound quite so unpleasant. Well, I should point out when I do reviews, which I'm usually over there, obviously, what I tend to do is focus on an individual thing and then try and do a take, and if I don't understand it very much, I usually gloss over it. And that's one of the areas that I've...
Don't give away your secrets.
I don't know if that's a secret, that's more like an admission. So the other thing, while I'm at it, I was going to ask briefly about the delay. You've gone for the BBD thing, and one of my other criticisms was it would be lovely if there was a sort of crystalline delay in there that you could maybe have a different alternative circuit to switch in, or you could get to that bit crushy clocked effect, or is there a reason you went? It does sound particularly authentic when you're in sort of analog mode. It kind of really adds to that whole sort of vintage vibe. But I'm guessing putting chips in there that would be able to work at higher rates and give you more crystalline wouldn't be too big a deal, or is it actually more complicated than I think? Maybe you know about that, Mark.
Yeah, in terms of bucket brigades, you're always going to have that kind of noise and aliasing depending on, because it's a balance of clock speed and number of buckets, and then if you have too few buckets for the time you're looking for, then you're going to get aliasing and those kind of digital things. I think that. The goal was that it's kind of a modular-based instrument. We wanted to have a vintage delay, and so...
No, that's fair enough. I do like the sound of the delay. It's just I thought it would be really nice if I could have one that wasn't vintage. The vintage, it sounds very authentically vintage and actually sounds really good. It's just that, having a kind of crystalline effect. But I guess then you're getting into possibly DSP and it, maybe.
There's no possibly about it. I think that the delay and I agree with you because it's my go-to. Like I like a clean digital delay on my analog synths. I do that all the time. But for clean crystalline delay, I don't think that there is an analog version of that that's not insanely expensive, not that you would build into an instrument.
Yeah, because I suppose we're getting back to those old sort of 2290s and the really expensive
right, or like
studio
Cooper,
delays.
we're going to build a Cooper time cube in there, like that would be nice. Only
yeah, fair enough.
So what you would want in that case is you'd want a nice digital delay, and people balk at that. At Moog, not everyone is on board with putting a digital delay in a old school analog instrument, and it's an understandable qualm. Like some people, that's fine. That's their two favorite things. Other people, it's anathema. So we have to strike a balance.
Okay, well, I stand corrected, and I can concede that point. I think I was probably just thinking. Normally, I might plug in well, I've got one in here. I was going to plug this guy in, which is the Zoom MS70 CDR, which is a great thing. But when I plugged it in, it had a bit of a hum to it, and I didn't want to misrepresent the sound. So, but there's some delays in there. That's easy enough to do. And it's a stereo in, stereo out affair, so that'll work nicely. But I think, gosh, we've talked for longer than I anticipated, actually, and I really do appreciate you taking the time, because I know at least it's part of your working day. I suppose you're able to join me during office hours, I suppose. But I do appreciate that, because the time difference can sometimes be a bit discombobulating. But guys, I really thank you very much for joining me. It's been a pleasure as ever. If I go back to this guy, so yes, I can always just ask casually. Oh, so I guess you're just both off now to work on something really cool now that you obviously can't tell me about it. Are you always working on new designs? I mean, is there sort of just this kind of conveyor belt of stuff, or is a lot of your time spent on? Well, I guess firmware tweaks, but you can't do hardware tweaks after the whole thing's gone. So I'm just curious.
It's fair to say that there is always something new in the works. Certainly this has been a very busy span of time. We are not resting on any kind of laurels. There's a lot in the works, and it'll all be very fun and exciting when it sees the light of day. Yeah,
I appreciate that. I mean, I think the thing is, one good thing, if there is a good thing out of coronavirus, is you get these kind of there's a lot less. There's more time to think about stuff. So innovation. Sure. I'm hoping. I'm guessing is probably going to be happening around the place. So so you got lots of employees coming in and go. I was thinking I've got this great idea for a new product. Put it on the shelf over there. We'll get around to it at some point, right? Yeah.
We have quite the list to work through. It's true.
Yeah.
Anyway, well, thank you once again, guys. Much appreciated. We will. I hope, and thank you all you folks in the chat room. Sorry, I didn't get round to ask.
Thanks, everyone.
Geosynthesis just a super sticker. Hey, that's cool. How very kind of you. Timeline Biggest Sky. Yes. So I think we covered. I saw them going past. Sometimes when I'm actually producing, it's hard to remember the names and stuff of people when you haven't got a producer. This is a solo producer, so I apologise if I maybe have said something to you without attributing. But the chat room is always appreciated, and very kind of you all to Wagyu with the super stickers and everything. So yeah, I'll be able to buy a pint later. Gentlemen, thank you so much for joining us. Really much appreciated. Thank you very much, Mark. Thank you so much. We will all see you all another time soon, and I look forward to more Moog, and I've been pretty good at saying Moog this time, stuff in the future. We'll see you all. Take care, guys.
All right.
See you later.
Thanks
Bye-bye
again.
now.
See ya.
Take care. Bye-bye.
Bye.